For number 7, it's asking about boiling and adding energy to boiling. Whenever a question is asking about phase changes, I like to consider a heating curve. So this is the temperature. So here we have a solid, and we raise the temperature until it starts to melt. Then here's the liquid phase. We raise the temperature until it starts to boil. And then we raise the temperature once it's a gas. So if you notice, I drew the particles of what a solid might look like. Notice that the particles are closely packed. Liquid, there's more distance between them. And then the gases, I actually can't even draw how they would be because my whiteboard is too small, but they're supposed to be very, very far apart. And notice they're flying all around. I did little flying things on there. So the question is asking, so on this boiling section, if I added energy, what would happen to the temperature? And it says it increases, decreases, doesn't change, or can't be determined. Whenever you're at the boiling point, so we can raise the temperature of the liquid, but during a phase change, melting, freezing, boiling, condensing, the temperature doesn't change. That's why it's flat here, to show that the temperature doesn't change. And that's because all that energy we're feeding into it, it says we're adding energy. Well, all that energy is being put into separating these particles. Notice these are close together, these are medium, and these are really far apart. How did they get far apart? There was energy to pull them apart from each other. It needs energy to pull those particles apart from each other. Think of them as little magnets. You know how when you play with magnets, they kind of stick together? Some are strong, some are weak, but it takes energy to pull them apart. And so all that energy we're giving to it, it's not heating it up during boiling, it's just pulling those particles apart.